2 is section 8.1, and it's going to be very tedious. Like I said, every problem should take me 2 sheets of paper, maybe bordering 3 sheets of paper. So each one of these problems has 3 equations and 3 unknowns. I'm going to have the answer written here, which means if I plug in 5 for x, -1 for y, and -2 for z into any of the 3 equations, I'm going to get a true statement. These problems take so long that I want to make sure to know the answer ahead of time, because I just wanted to speed up the process. And I'm not going to do the checking, but you can do the checking for this problem after you get your answer, plugging each of the values in. Like this, like if I went to the top equation, I could go 3 times 5 minus 2 times -1 plus -2. That should be 15. This gives me 15 plus 2 minus 2 equals to 15, which gives me 15 equal to 15. That point works in the top equation. It will work in the middle equation. It will work in the bottom equation. So my hint to this is to help you get started. We need to do the elimination method ultimately 3 times to do problem 38. And my hint was take the bottom equation, pair it with the other 2. Let me start. Here's my bottom equation. X minus y minus 4z equals 14. I'm going to pair it with the other 2 equations, which is the middle and the top equation. Really? Okay, so I took the bottom equation. Now I'm going to pair it with the top equation, which is 3x minus 2y plus z equal to 15, and pair it with the middle equation, -x plus y plus 2z equal to -10. So the first step in solving a system that has 3 equations and 3 unknowns is to pick one equation, pair it with the other 2. So that's it doesn't matter which equation you pair with the other 2. Sometimes I'll pair the top with the other 2. Sometimes I'll pair the middle with the other 2. There isn't a right and a wrong thing to do. You just have to make a decision and commit. So my first step is going to be taking one of the equations and pairing it with the other 2. So that's what I've done. I've paired the bottom equation with the top equation, the bottom equation with the middle equation. I have to decide on a letter to drop out. For whatever reason, I decided to drop out the z's. So from both of these, I'm going to eliminate the z's. So in this one, to eliminate the z's, I'm going to make the bottom have a positive 4z. The top already has a negative 4z. That will help me eliminate the z's. So I'm going to leave the top at x minus y minus 4z equals to 14. Multiply everything in the bottom by 4, which will give me 12x minus 8y plus 4z equals to 60. I'm going to eliminate the z's, or drop out the z's, by adding these together. 12x plus 1x is 13x, minus 1y minus 8y is minus 9y. Z's cancel. 60 plus 14 is 74. So that's half of the first step. So the first step, I decided to pair the bottom equation with the top equation, the bottom equation with the middle equation, drop out the z's. Another step here, do the same thing with this. I'm going to drop out the z's by making a positive and a negative 4z. I'm going to leave the x minus y minus 4z alone. Multiply here by 2, get negative 2x plus 2y plus 4z equals to negative 20. And I'm going to add these together. Negative 2x plus positive 1x is negative 1x. Negative 1y plus positive 2y is positive 1y. My z's cancel, and 14 and minus 20 is negative 6. Now, that's the end of step 1. So step 1 was to pair the bottom equation with the other 2 and drop out the z's. Now I'm going to stack my answers. I came up with the answer, 2 different equations with the z's dropped out. There were 13x minus 9y equals to 74, and minus 1x plus 1y equals to negative 6. You don't need the ones, but I sometimes like to write the ones. Now I'm going to solve these problems just like they're from the beginning. Specifically, I'm going to drop out the x's. I'm going to use the elimination method. I'm going to solve by dropping out the x's. This is going to lead me to the top equation staying at 13x minus 9y equals to 74. So I'm ignoring this whole top part for probably for the rest of the time. I'm only looking at this like it's a problem by itself. Multiplying through to use the elimination method here, it's going to give me negative 13x plus 13y equals to negative 78, I believe. And then combining these, the x's cancel. Negative 9y plus 13y is positive 4y. 74 minus 78 is negative 4. Divide both sides by 4, and I get y equal to negative 1. If I look at what I wrote, I said y equal to negative 1 was part of the answer. That's good. So I'm 1/3 of the way through to my answers, but more than 1/3 of the way through my work. So I'm only looking now at this system of equations, ignoring the beginning for a while and doing everything I can with this system of equations. I was able to get an answer for y. I'll also be able to get an answer for x. So just with these two equations, I can get an x and a y, and I'm going to do that. So I'm going to use the equation negative 1x plus 1y equal negative 6. Plug negative 1 in for y. I'll go negative 1x plus 1 times negative 1 equals negative 6. This gives me negative 1x minus 1 equals negative 6. I'll add 1 to both sides. That gives me negative 1x equals negative 5. Divide now by negative 1. Divide by negative 1. And that will give me x equal to 5. 2/3 of the way through to my answers, probably more than 2/3 of the way done with my work. If you looked at my initial problem I said x was 5, y was negative 1, z is negative 2. That's the only thing left that I have to get. So I've done enough algebra by pairing the bottom equation with the other two, dropping the z's, taking the results of that, stacking them using the elimination method, gave me an answer for x at 5, y of negative 1. I need to find a z, and so this is my x. Here's my y solving, and now I'm going to sneak in a z solving. To get a z solved for, I need to find any equation in this problem and pick it and plug the values in for x and y that I know and solve for z. I'm going to take that equation right there, that equation that says 3x minus 2y plus z equals to 15. And specifically, I'm going to plug in 5 for x. So I'm going to go 3 times 5 minus 2 times, I'll plug negative 1 in for y, plus z equals to 15. Do the math. 3 times 5 is 15. Minus 2 times negative 1 is plus 2. Plus z equals to 15. This gives me z plus 17 equals to 15. I minus 17 from both sides, and I get z equal to negative 2. The 3 components in my answer are x equal to positive 5, y equal to negative 1, z equal to negative 2. And when I write my answer, I write it as a ordered triple. So the answer is going to be x equal to 5, y equal to negative 1, z equal to negative 2, and you write them in that order. You write alphabetically x, y, then z. And then again, I'm skipping the checking just to save a little bit of time. Otherwise, it's going to take me longer than you probably care for me to take. So that's that problem. All the problems work the same unless the letters drop out, and then it gets a little bit different. In 40, I was so confident to say start any way you like. That's a little bit of overconfidence. What I'm going to do, by starting, I need to pick an equation and drop out, pair it with the other two and drop out the letter. There isn't a right and a wrong thing to do, but there's probably an easy and hard thing to do. I'm going to pair let's pair the top with the other two. And I'm going to drop out the y's. So what you need to do for your very first step is decide on one equation that you're going to stack on top of the other two equations, and you need to decide on a letter to drop out. I decided to take the top equation, negative 5x, new sheet of paper because it just saves the room. I'm going to take the top equation, negative 5x minus y plus 3z equal to negative 14, and take that and write it directly on top of the middle equation and directly on top of the bottom equation. So my top equation I'm pairing with the other two. The other two are the negative 2x plus 2y minus 6z equal to 16, and x plus 7y plus 2z equal to negative 5. So always when I have three equations and three unknowns, my very first thing to do is pick one of the three equations and write it on top of the other two. So that's what I did. I took the top equation as opposed to the bottom or the middle equation, put it on top of the other two. Now I decided I'm going to drop out the y's. And there isn't a right or wrong thing to do, but you need to commit to something, and I'm going to drop out the y's. For this first set, I'm going to multiply the top by positive 2 to make my y's drop out. When I do that, I'll get negative 10x minus 2y plus 6z equals to minus 28. That's taking everything in the top equation and multiplying it by 2, leaving the bottom equation minus 2x plus 2y minus 6z equal to 16. When I add the equations together, I get negative 12x, y's cancel, z's cancel, which is actually good, equals to negative 12. Do the same for the next set of equations. I'm going to make the y's drop out again. I'm going to multiply the top by 7. I'm going to go 7 times negative 5x is negative 35x. 7 times negative y is minus 7y. 7 times 3z is plus 21z. And then 7 times minus 14, I believe, is minus 98. So 7 times 14, yeah. I'll leave the bottom one, x plus 7y plus 2z equal to negative 5. When I add these together, negative 35x plus x is negative 34x. The y's cancel. 21z and 2z is 23z. And negative 98 and negative 5 is negative 103. So something good happened over here that doesn't often happen. When I go to stack these two equations on top of each other, it normally would happen that both would have an x and a z when I'd have to use the elimination method. This is a special problem. This happens occasionally, but not frequently. If I take this, so now I have two equations that I'm working with. This equation, negative 12x equals negative 12, and this equation, negative 34x plus 23z equals negative 103. Normally I'd stick those on top of each other and use the elimination method, but I don't have to in this case because this equation by itself, because it only has an x, gives me an ability to solve for x. So I'm going to use this equation and take that advantage of that. Divide both sides by a negative 12. When I do that, I get x equal to 1 without even stacking these two equations on top of each other. By just using this equation alone, I'm able to get an answer for x. I can take that answer for x and help me get my z. Let me make sure I haven't made a mistake because I know the answer ahead of time was x equal to 1. When we get into the next section, I'll show you how to use a feature on your calculator to get the answer ahead of time so that when you're actually doing a problem like this on a test, you'll know the answer ahead of time anyway. So having the answer ahead of time won't be magical, but I can't do the calculator activity until we get to the next section. So I'm going to use this 1 for x and go negative 34 times 1 plus 23z equals negative 103. This gives me negative 34 plus 23z equals negative 103. I'm going to add 34 to both sides. Negative 103 plus 34, not that you probably could see that, but I get negative 69. So this gives me 23z equals negative 69. Now I'm going to divide both sides by 23. Negative 69 divided by 23 gives me negative 3. So I get z equal to negative 3. So I have a value for x, a value for z that match up, and now I want to get a value for y. To get a value for y, I can take any of the equations in this problem that have a y, plug 1 in for x and negative 3 for z. Apparently I'm going to get y equal to 0. I like working with positives. I'm going to work with the middle equation. So I'm going to solve for y, because that's the only thing I have left to come up with. I'm going to take this equation. Maybe that equation's better. I'm going to take that. They're both good. I take this equation. It's got more positives. I'm going to use the equation x plus 7y plus 2z equal to negative 5. I'm going to plug in 1 for x, leave the 7y alone, plug in negative 3 for z, and still equal to negative 5. So I get 1 plus 7y plus 2 times negative 3 equals to negative 5. This gives me 1 plus 7y minus 6 equals negative 5. On the left-hand side, 1 minus 6 is negative 5. So this gives me 7y minus 5 equals minus 5. I'm going to add 5 to both sides. That gives me 7y equals to 0. And then I divide both sides by 7. I get y equal to 0 over 7. And any fraction with 0 in the numerator is 0. An answer of 0 doesn't mean no solution. So the answer to this is x equal 1, y equals 0, z equal negative 3, and usually we write the answer as a point, or ordered triple. So I'm going to say the answer is 1, 0, negative 3. Again, in the next section, before we actually get to the test, I'll show you how to generate that answer via your calculator without having to do the algebra, so you know the answer ahead of time. Now I have to worry about the checking part of it. That's going to take more time than we might have to spend on this problem. So for each one of these problems, what I start off doing is I pick an equation, pair it with the other, drop out a letter. Do the same thing with 42. I'm going to take the top equation, pair it with the other two, and drop out the x's. So that's what I'm going to do. I'm going to pair. And the reason I'm taking the top and dropping the x's is because it's the only negative. I like negatives and positives that cancel. So I'm going to pair the top with the other two and drop the x's. Which means I need to write that top equation down, negative x plus y plus 2z equals to 1 twice. Once I put it on top of the middle equation, once I put it on top of the bottom equation. So now I've done what I decided to do. I paired the top equation with the other two. There isn't anything right or wrong about what I did, but on the first step, you have to take one of the equations and pair it with the other two. So I started off by doing that. And you have to pick a letter to drop. I decided to drop the x's. My goal is to get this answer, x equal to 2, y equal to negative 3, z equal to 3. That's my goal. If I don't get that, then I'll hunt around for my mistake, because I'll have a mistake if that answer is correct. So to drop the x's, I'm going to multiply this equation by 2. I'm going to get negative 2x plus 2y plus 4z equals to 2 on top of 2x plus 3y plus z equals to negative 2. Now you can barely see that negative. When I add these together, x's cancel. I get 5y plus 5z equal to 0. That's not a no solution. My variables didn't drop out. 0 is just another number. For this other side, I'm going to multiply by 5 and get negative 5x plus 5y plus 10z equal to 5 on top of 5x plus 4y plus 2z equal to 4. X's cancel. I get 9y plus 11z equals to 9. I'm going to stack these equations on top of each other. I'm going to do something slightly slick that you're allowed to do. Anytime you look at an equation, if every number is divisible by the same number, it's legal to do that division and work with a simpler form of the equation than the algebra produced. And this equation, the 5y plus 5z equal to 0, everything is divisible by 5. If I divide everything by 5, I get y plus z equal to 0. That I can use instead of the 5y plus 5z, and that's probably going to be better. So that's the end of my first step. I paired the top equation with the other two. I dropped out the x's. Now I'm going to stack these. I shouldn't have had this line go so far. Specifically, I'm going to stack y plus z equal to 0 on top of 9y plus 11z equals to 9. I want to drop out a letter, use the elimination method. I'm going to make a negative 9z. I'm going to multiply this top equation by negative 9. When I do that, I'm going to get negative 9y minus 9z equals to 0, because negative 9 times y is negative 9y, negative 9 times z is negative 9z, negative 9 times 0 is 0. I'm going to put that on top of the 9y plus 11z equals to 9. Add these together, the y's cancel. I get that I've made a mistake, because I get 2z equals to 9, and I get z equals to bad things. I get z equals to fraction. It's not going to be a fraction. The answer to this is supposed to be z equal to negative 3. That certainly doesn't look like a negative 3, so I need to hunt around. Oh, I see a mistake already. When I did this here, I did 10z plus 2z. I wrote 11z. That's not a good thing. I should have written 12z, which makes this a 12z, which makes this a 12z, which makes this a 3z. So I should have gotten 3z equals to 9. So the beautiful thing about having the answer ahead of time is you can start to see your mistakes. But I think it's supposed to be negative, and I'm getting positive 3. So this is going to happen when you're sitting by yourself doing these problems. This is the pain of these problems, is that you can do perfect algebra. Oh, duh, I was looking at the wrong solutions. Z is positive 3. Good deal. So I found my mistake. When we get through the next section, I will teach you how to know the answer to the problem before you do your algebra, so that you can get into the position that I just got into. I got into this position where it's like, oh my gosh, my z isn't going to come out to be 3 and it was supposed to be 3. Then I can hunt and find my mistake before I get to the end of the problem. So I have z equal to 3. I need to solve for y. I'm going to use this equation. So I'm going to solve for y. I know that y plus z equal to 0 and z equals to 3. So I can go y plus 3 equal to 0, minus 3 from both sides, and I get y equal to minus 3. That's getting me there, because the answer is supposed to be x equal to 2, y equal to negative 3, z equal to 3. 2/3 of the way there. I need to pick any equation that has an x. I like this equation, well, this equation right here. This equation, 5x plus 4y plus 2z equal to 4. If I use that equation, plug the negative 3 that I just found to be y, the 3 that I found to be z, I'd get 5x minus 12 plus 6 equals to 4. That would give me 5x minus 6 equal to 4. I add 6 to both sides, I'd get 5x equal to 10. Divide both sides by 5. I get x equal to 2, x equal to 2, y equal to negative 3, z equal to 3 is my solution. So they're very tedious. They involve doing the elimination method 3 times. There's one substitution method here, one substitution method there. So mostly these problems require 3 elimination methods and 2 substitution methods. That's unless you get no solution or you get infinitely many solutions. And that's what we're headed to next. So we only did 3 problems with, is that all? Or did I do 4 of these? There's 38 was one, 40 was another, this was just 42. Let me do one more outside the text before I do one of the text problems because I'm not sure that was enough. So let me pick one more set of problems. Did we do this one? I don't think we did this one. Let's try this equation. This is extra problem. 2x minus y plus 2z equals to 2. This is problem 6. 3x minus y plus z equal to 3. And x plus y plus z equal to 7. And I claim that this is the solution. So I'm going to do this before I move on to the other style of problems because this is what's going to make it onto the test. For these style of problems, the chances of me putting a no solution or infinitely many solutions is next to 0. So if this was a test question and I asked you to solve this, you need to be clever, pick an equation and drop out a letter. I'm going to pair the bottom with the other 2. I'm going to drop out the y's. So this is just an extra, not from the homework, just because I wasn't sure we had enough practice yet. The reason I picked the bottom equation and dropped out the y's, because it looks like it was going to be easy. I'm going to put this x plus y plus 3 on top of the top one, on top of the middle one. The y's are going to be super easy to drop out. My goal is to get x equal to 2, y equal to 4, z equal to 1. Again, I'll show you eventually on the next lecture how to do this via your calculator. It's easy to do on your calculator, but it doesn't fit with this section. It's the stuff in the next section. So I take the bottom equation, x plus y plus z equal to 7. Put it on the top equation, 2x minus y plus 2z equals to 2. And the middle equation, 3x minus y plus z equal to 3. So my goal again is to get x equal to 2, y equal to 4, z equal to 1, because that is the answer to this. We actually checked this when we did problem 6. The nice thing about pairing like this and deciding to drop out the y's is the y's are set up to drop out. So now I can just add the equations together. This one's going to give me 3x, y's will cancel, plus 3z equals to 9. This one's going to give me 4x, y's are going to cancel, plus 2z equals to 10. I could stack these on top of each other the way they're written. Wouldn't be anything wrong with that, but I can be slick. This equation, everything is divisible by 3. So before I stack these on top of each other, I could divide through by 3 and get x plus z equal to 3. Similarly, these are all divisible by 2. And before I stack these on top of each other, I can go 2x plus z equal to 5. Doing that division is going to make the stacking or the elimination method next a lot easier. And that's going to be the case for any of the problems. Anytime we have an equation where every number is divisible by the same number, you can divide by that. So now I'm going to stack these. So I decided first, I picked an equation, paired it with the other 2, decided the letter to drop out, drop that letter out. Now I have the typical 2 equations to stack on top of each other. Need to drop out a letter. I'm going to drop out the z's. I'm going to make the top have a minus z. I'm going to multiply by minus 1. The top's going to become minus 1x minus 1z equal to minus 3. I'm going to leave the bottom 2x plus, I'm going to emphasize 1z equal to 5. When I add these together, negative 1x and 2x is x. Negative 3 plus 5 is 2. Remember, my goal is to get x equal to 2, y equal to 4, z equal to 1. There's my x equal to 2. Now I'm going to solve for z. I'm going to use this equation, x plus z equal to 3, and plug in 2 for x. So I'm going to get 2 plus z equal to 3 minus 2 from both sides. That's going to give me z equal to 1. Last thing I need to get is this 4 for y. I'm going to use the top equation. X plus y plus z equal to 7. Plug in 2 for x, 1 for z. That gives me 2 plus y plus 1 equal to 7. That gives me y plus 3 equal to 7. I minus 3 from both sides and get y equal to 4. So my answer, that can be checked, but it takes a long time to check, is x equal to 2, y equal to 4, z equal to 1. So that's likely what you're going to get on the tests from this section with 3 equations and 3 unknowns. There's a slim chance that I give a no solution. There's a 0.0000001% chance that I give you an infinitely many solutions, so I wouldn't fret that so much. But let me show you what happens when you get a no solution. When you get a no solution, at some point, the letters are going to drop out and you're going to be left with a false statement. That's the case for both problems 46 and 48. And then when we get to problem 50, this is 44 and 46 are going to be no solutions. 48 and 50 are going to be infinitely many solutions. At least watch 44 and 46. Those won't be bad. 48 and 50, if you don't feel the urge to watch them, because I'm virtually certain I wouldn't put those on a test, then that's fine. It can't hurt to see, but it's okay if you don't see it. So pair the middle equation with the other two and drop out the z's was my hint. So I'm going to take this middle equation, no solutions don't take up that much room. My middle equation is negative x plus 2y plus z equal to 5. I'm going to pair that with the top equation and the bottom equation. So for every time I do these, I pick an equation, pair it with the other two. Doesn't matter if you take the top, bottom, or the middle equation. You just have to decide which one you want to do. So I just paired the top equation with the other two. The reason I said to drop out the z's is because I knew they were going to be easy to drop out. The z's could be dropped out without any multiplication. So I'm going to add these together. Negative x plus 2x is positive 1x. 2y minus 3y is negative 1y. The z's cancel. 5 plus 0 is 5. For these, negative x plus 3x is positive 2x. 2y minus 4y is negative 2y. Z minus z's cancel. 5 and 1 is 6. I can take this equation and divide them all by 2 if I wanted. That's going to give me x minus y equal to 3. I'm going to stack the equations on top of each other. The x minus y equal to 5 and x minus y equal to 3. I'm going to multiply the top equation by minus 1. It's going to make both the x's and y's cancel out. When I multiply the top equation by minus 1, I get minus x plus y equal minus 5. I'm going to stack that on x minus y equal to 3. On the left side, both letters cancel out. On the right side, I get negative 2. That's the best thing that can happen. That's the least amount of algebra I could ever have to do. The letters drop out and I'm left with a false statement. There's no solution. So the answer to 44, you can say the word inconsistent. That's an elegant way saying that there's no solution. Or you can say there's no solution. Once we get to the point where all the letters drop out, if I'm left with a false statement, like 0 equal to negative 2, I'm done. Same thing's going to happen in 46, or something similar is going to happen in 46, meaning the letters are going to drop out and I'm going to be left with a false statement. So when I go to do 46, again, I gave you a hint. It's a similar hint. Pair the top equation with the other two and drop out the z's. My hint for 48 is not a good hint. I'll have to recalibrate that hint when I do 48. Okay, so I'll follow my hint in 46. I'll change my hint in 48. So pair the top equation with the other two. Drop out the z's. Again, these don't take that much room, so I'll do it right on this. Top equation, 3x minus 2y plus 2z equals to 6. There's my top equation. There's my top equation again. 3x minus 2y plus 2z equal to 6. Pair it with the other two. So I'm going to pair it with 7x minus 3y plus 2z equals to negative 1. I'm going to pair it with 2x minus 3y plus 4z equal to 0. Make the z's drop out. For this one, I'm going to multiply this one by negative 1. It's going to give me a negative 3x plus 2y minus 2z equals to negative 6. I'm going to stack that on 7x minus 3y plus 2z equal negative 1. When I do that, I get 4x minus y equals to negative 7. For this pair, I'm going to multiply this by negative 2 and get negative 6x plus 4y minus 4z equals to negative 12. Put that on top of 2x minus 3y plus 4z equals to 0. Add these together. I get negative 4x plus y equals to negative 12 because the z's cancel. Let's stack these on top of each other. So I'm going to go 4x minus y equals negative 7, negative 4x plus y equals negative 12. And these are ready. If you add these, the x's and y's cancel. Negative 7 and negative 12 is negative 29. The letters cancel. I have a false statement. So my answer is either going to be the word inconsistent or say no solution. Either would be okay. The next two, 48 and 50, again, if you shut the video down, it wouldn't make any difference in terms of the test. If you're going to be a math type major, if you're going to take linear algebra, math 342 at ASU, it probably would be worth watching. If you're not going on to linear algebra ever in your future, it's not such a big deal. I need to change my hint. And in this problem, all the letters are going to drop out, and I'm going to get a true statement like 0 equal to 0. My answer needs to look like this. The set of all x, comma, y, comma, z, such that x equals something, y equals something, and then for any real number z. So I'm going to do a bunch of algebra, and ultimately the letters are going to drop out, and I'm going to get a 0 equal to 0. When the algebra leads me to a 0 equal to 0, or the letters drop out, and I'm left with a true statement, then there's quite a bit to do to write my answer in an elegant way, and we'll get to that when I get to that. But I'm not going to drop out the z, so that elegance isn't going to help. Let me pair the bottom with the other two and drop out the x's. This dropping out the z's when there's infinitely many solutions creates more work for yourself. So I won't drop out the z's, otherwise it'd be silly to do. I'd be making more work than I need to. So I'm going to take the bottom equation, x plus 5y plus 3z equal to 2. Pair it with the top and pair it with the middle. So x plus 5y plus 3z equal to 2, written twice. Pairing it with the top equation, 2x minus 3y minus z equal to 0. Pairing it with the middle equation, 3x plus 2y plus 2z equal to 2. I'm going to drop out the x's. So my modified hint, pair the bottom with the other two and drop out the x's. That my answer is going to look funky, but I'll get to that in a second. To drop the x's out here, I multiply by negative 2. I get negative 2x minus 10y minus 6z equal to negative 4 on top of 2x minus 3y minus z equal to 0. When I add these, I get 0. I get a minus 13y, a minus 7z equal to minus 4. For the next set, multiplying by negative 3, I get negative 3x minus 15y minus 9z equal to negative 6. Put that on top of 3x plus 2y plus 2z equals to 2. Add these together. X's cancel out. I get negative 13y minus 7z equals to negative 4. They're exactly the same. When I stack these on top of each other, they don't cancel until I multiply one of them by a negative 1. So I'm going to take the top, multiply it by negative 1, and get 13y plus 7z equal to 4 on top of 13y plus 7, I should say z there, z equal to 4, negative actually, or negative 13. Top turns into all positives, bottom stays all negative. So the top, this turns into 13y plus 7z equals to 4. The bottom stays minus 13y minus 7z equal to minus 4. When I add these together, I get 0 equal to 0. Once I get to the point where I see 0 equal to 0, and there's an x, y, and z, I know my solution needs to be in this form. After the x needs to be something in the form, something with only a z. After the y, there needs to be something with a z. So what I'm going to do at this point is take this equation, or one of these equations, probably this one, and solve it for y. And I'll write that in my answer next to the z. So I'm going to solve this equation, 13y plus 7z equal to 4 for y. Specifically, I'm going to minus 7z from both sides. That's going to give me 13y equals minus 7z plus 4, and divide by 13. Which is going to give me y equals negative 7 over 13z plus 4 over 13. In my answer, I'm going to write that next to the y. So my answer is going to be the set of all points of the form x, y, z, such that y equals negative 7 13th z plus 4 over 13 for any real number z. I need to have the same thing next to the x. I need to have the x solved for in terms of z to finish out my answer. So I started the problem regularly. I picked two equations, dropped out the x, did my elimination, got to a 0 equal to 0. Then I was able to take that equation and solve it for y. The next step to do is to pick a pair of equations and drop the y. So to get what goes in front of the x in my answer, pick any two equations, and drop the y's. And I'm just going to take the top two equations. The top equation was 2x minus 3y minus z equal to 0. The bottom equation was 3x, or the middle equation is 3x plus 2y plus 2z equal to 2. I'm going to drop out the y's by multiplying this equation by 2, that equation by 3. This is going to give me 4x minus 6y minus 2z equal to 0 on top of 9x plus 6y plus 6z equal to 6. When I add these together, I get 13x plus 4z equals to 6. I want to solve this for x. I'm going to minus 4x from both sides. I'm going to 4z from both sides. I get 13x equals minus 4z plus 6, and then I'm going to divide. everything by 13, and I get x equals minus 4 over 13z plus 6 over 13. That's what I'm going to write in my solution next to the x equals. I'm done. There's so much more that I could do to talk about why this solution how you can use this solution, but that's really more appropriate for Math 342, which this isn't. So I'll tell you how to write the solution, and that's it, and not really explain the solution. But again, if you're curious why we write the solution like this, or what it can be used for, come visit me and I'll spend some time with you. Probably take me a good half hour to work through a problem and talk about why the solution is written this way, how it's relevant to anything, and that really is probably beyond the scope of the class. So that would be the proper answer for 48. I'll do 50 the same way. So if you were inspired enough to watch 48, you can watch 50 again. The chances of me putting a problem on the test that has infinitely many solutions, that has 3 equations and 3 unknowns, is virtually 0, so you won't have to worry about it. So my answer for 50 is going to be in the form, the set of all x comma y comma z such that x equals something, y equals something for all real numbers z. So I'm going to, again, telling me to drop out the z's was a horrible idea. I'm going to pick the top equation with the other two and drop out the x's. If you drop out the z's, it defeats the purpose of having an equation with a z. You need lots of z's going around when you're writing your solution. Dropping out the z's is a bad thing to say. For both 48 and 50, my hints were really horrible hints. So picking top equation, dropping out the x's is an okay thing to do. So the top equation was x minus 2y minus z equal to 8. I'll put that twice. So this part I wouldn't know by looking at the problem that I'm going to get a 0 equal to 0, but you would after we get to our calculator activities that will help us in the next section. So I'm impressed if you actually stayed and watched this far. That's, well above and beyond the call of what you need. I guess if you watched this far, send me an email telling me you actually watched this, and maybe I'll be kind and give you an extra credit point or two for making it this far. Anyways, I'm going to drop out the x's. I'm going to multiply this one by negative 2, and I'll get negative 2x plus 4y plus 2z equals to negative 16 on top of 2x minus 3y plus z equal to 23. When I stack these, I get y plus 3z equals to 7. For the next pair, I'm going to multiply the top by negative 4, and I'll get negative 4x plus 8y plus 4z equals to minus 32 on top of 4x minus 5y plus 5z equal to 53. This gives me 3y plus 9z equals to 53 minus 32, I think is 19, but I'm fading right now, so I'll use my calculator. 21 it is. This equation, I'm going to divide everything by 3 because it is all divisible by 3. And when I do that, I get this y plus 3z equals to 7. That's good. So I'm going to take this one, y plus 3z equal to 7, stack it on top of this y plus 3z equal to 7, multiply the top by negative 1. That gives me negative y minus 3z equal to negative 7 on top of y plus 3z equal to 7. That gives me a 0 equal to 0. When I get a 0 equal to 0, then I have some work to do. For my answer, I need to find an equation and solve it for y. Easy enough to solve this for y. So this equation, y plus 3z equal to 7, if I minus 3z from both sides, I get y equals minus 3z plus 7. That's going to go in my answer. So in my answer, next to the y, I'm going to put a minus 3z plus 7 because that's what I got when I solved one of these equations for y. Now I need to come up with an equation with an x and a z. So I need to pair some equations and drop out an x. So to finish up this problem, or pair some equations and drop out a y, I need to pick two equations and drop out the y. So I'm going to take the top equation, x minus 2y minus z equal to 8, and the middle equation, 2x minus 3y plus z equal to 23, and I'm going to drop out the y, and that'll allow me to get something next to the x that's appropriate. I'm going to multiply this by negative 3, this by positive 2, and when I do that, I'm going to get negative 3x plus 6y plus 3z equals to negative 24. This multiplying by 2, I'm going to get 4x minus 6y plus 4z equals to 46. Add these together, I get x plus 7z equals to 22. Solve this for x by minusing 7z. I get x equals minus 7z plus 22. And that's what I'm going to write next to the x equal in my solution blank. So x is negative 7z plus 22, comma between. That would be an appropriate way to write the solution to number 50. There might be other ways that are equivalently correct and maybe slightly more elegant, but this is as good as it can be. Again, the 48 and 50, the chances of those coming on the test are about 0. The no solution ones, even with the 3 equations and 3 unknowns, they're not very likely to make their way onto the test either. But the infinitely many solutions with the x and the y only, that could come on the test. So that's not being precluded by me saying these big ones aren't on the test at infinites. All right, so that's that section. The next section is real similar in the way the problems look. Not so similar in the way that we solve them. I don't know which is going to be more or less unpleasant, but today's hopefully is less pleasant than tomorrow's.